This is going to be the walkthrough for exercise 1, creating JUnit tests. So what we're going to do is use the JUnit testing framework to create some tests for some sample classes. I've gone ahead and downloaded JUnit sample solution from Blackboard and saved it to my computer. I've also gone ahead and opened up NetBeans, and what I've done is I've actually created not a Java application but a class library. Using the JUnit framework to create tests is really nice if you are tasked with building a class as opposed to an application. While you could write an application to test your class, you don't need to. What you can do is build JUnit tests, and when you publish and make that application library available, while the tests that you write will stay with your code, they won't be accessible to whoever's using it. So you can keep everything together in one place and not worry about it when you go to publish your code so that other people can use it. So I've created the class library, and I've created the project with the name of JUnit sample. I've gone ahead and set my storage locations, and let me close this. And I've gone ahead and created a source package called sample. And you do that just by right-clicking on package, going to new, and saying Java package. And we're going to actually stick everything in our sample package. I'm going to go ahead and open up the solution that I downloaded. While that solution actually has everything in it, what I want to do is just copy a couple of files over out of that project. So let me go grab that. As you can see, I have a lot of stuff on my computer. So I'm going to open up that's the solution. Whoops. Grabbed the wrong one. Here we go. And then I'm going to take the util and vector packet, the vector classes, and I'm going to move them up into my JUnit sample program. And everything looks good. I'm going to hit the refactor button. I'm going to close JUnit solution. And now I have my util and my vector class. We're going to start by creating a couple of tests for our vector class. Now, if we look at this class, let's just take a quick look at this. This is a sample utility for performing vector algebra. Vectors are essentially arrays of numbers that are multiplied, and they can be multiplied together. We can also check for equality. So we have these two methods in here, and what we're going to do is we're going to write tests to make sure that these methods work. And to do that, we're going to go over here to our project, and we're going to click on the vectors.java class. We're going to right-click on it, and we're going to go down to Tools, and then we're going to do create/update tests. Now, you may only see create tests, that's okay. I'm actually running a more current version of NetBeans than we currently run in the classroom. And I'm doing this because the static code analysis that I want to show you a little bit later today is not available in NetBeans 7.1. It's only available in NetBeans 7.2 or higher. So I went ahead and went out and got the most current version of NetBeans available. We're going to modify the name of the test to vectors JUnit 3 test. And we're going to make sure we're going to uncheck the box for test initializer and test finalizer. Now, by leaving these all here, what happens is it creates some methods for us. It pre-writes a lot of our stuff. If you get prompted to pick which version of JUnit you're running, some of the newer versions of NetBeans support JUnit 3 and 4. Some only support 3. We're going to stick with 3 just because I know all of the computers can do it. We're going to click Select. And we now have a section over here called test packages. And inside the test package, we have a file called vectors JUnit 3 test, which is just what we created. You're going to notice up at the top that we see import statements. We see a JUnit framework.test case and sample.vectors. Sample.vectors is the class that we're testing. That's this right over here. And JUnit.framework.test case is the library that provides us our testing capabilities. Notice that we've created a class that extends what they call a test case, and we have a number of methods here. We have a constructor that takes the name of the test and passes that along to our to the test case class constructor. We have a test equals and a test scalar multiplication method as well. Now, the tests that they have here really don't do a whole lot for us. So we're going to have to change this around a little bit. This is sort of a default test case. And so what we're going to want to do is create our own test for this method based on how this method works. Now, I have provided you with some code. So the first thing we're going to do is we're going to change the system.out.println message to say star vector JUnit 3 test scalar multiplication. And basically what this is going to do is just output the name of the testing class and the name of the method, so I know when I'm looking at the results in the command prompt what exactly I was doing. What was the point of all this? And then I want to add some code in to test the different types of the different possibilities for multiplication. So I'm providing a couple of arrays with some different data in it and what I expect the results to be. In this, we're going to be using what's known as the assert equals statement. Now, what does the assert equals method do? It takes two arguments. First, it takes whatever result we're expecting, and then whatever it is that is going to produce those results. So if you look at the code that we have in the handout that was in the exercise before you watch this walkthrough, you'll see that in the first example, which let me put in here for you, we're calling assert, that means make sure, equals, that means that whatever I'm testing, they're going to have to be the same. This is the answer that I expect, 0. And I expect that if I call vectors dot scalar multiplication new and create an integer array that contains the values 0, 0, and another integer array that also contains the value 0, 0. Now, I don't know a whole lot about scalar multiplication. It wasn't something that I studied very hard in math class, some 15, 20 years ago. But what I can tell you is what this statement is saying is that the result of calling the scalar multiplication function and providing it two integer arrays of 0, 0, and 0, 0 should give me back the answer 0. If these two match up, then everything will be fine and the program will continue running. When we're using assert equals, if both sides of that, both arguments, the result of both arguments of that assert equals are not identical to each other, the whole thing is it's gonna blow up and it's gonna provide us with an exception. Now, I realize we have not talked about exception handling yet, but an exception is essentially a runtime error. It's going to provide us with a runtime error. So I'm going to go ahead and I'm going to finish putting in these assertion statements. And we're going to review the results of this. Now, when you're writing these assert equals, you want to check a range of values. You want to check out every possibility. So in the case of our example here, I want to check to see what happens when it's 0, 0. I want to check to see what happens when it's two positive numbers and two positive numbers, an array of two positive numbers against a second array of two positive numbers. I want to check out what the result is of an array of a positive and negative number and a positive and negative number. I want to check out the result of a positive number, an array of only positive numbers, an array with a positive and negative number. So we want to make sure that we're checking all possible combinations of values when we're doing our testing. I realize we're not going to be able to test every possible number, but when you're writing these tests, you want to make sure you give enough test coverage to cover all cases. So think about your decision statements. If you're writing a test for a decision statement, you want to make sure you hit all possible branches of that decision statement. So if you're testing to see if they got an A, a B, a C, or a D to take a certain set of actions, when you're testing to make sure everything works, you need to make sure that you test what happens when they get an A, what happens when they get a B, what happens when they get a C, what happens when they get a D. One of the hardest things about testing is making sure that you come up with good enough test coverage. Too little test coverage, and you risk putting out software with major flaws. Too much test coverage, and you're wasting time. And in this industry, time is money. And so it's very important not to overdo it, but also not to underdo it. There's a very fine line. So I'm going to go ahead and I'm going to put in the rest of my assert statements, and then we will take a look at the results of this program when I'm finished. Now, when we're ready to run our test, it's as simple as running it like any other program. We can just right-click on the file and say Run File. Now, what we get is this little pop-up window that says Tests Finished Successfully. This window is called the test results window, and anytime you're running tests, you're not going to get output. Instead, what you're going to get is this. And it says that all tests have passed. That means that I got the values that I was expecting from all of these assert equal statements, ran successfully, and I got the expected value out of every one of them. Now let's change one. Let's take this negative 39 here and say, oh, we're expecting 15. and let's run it and see what happens. Again, to run, I'm going to right click and go to Run File. And my test failed. My test failed. Well, why did it fail? It failed because one of my assert statements was incorrect. And if I can pop these out and see where my failure was. So it was in test scalar multiplication, and it was on line 29 of my program. And it said, well, I was expecting 15. That's what I put in my assert equals. But the result of this method call here was negative 39. So that's a problem. So either my scalar multiplication isn't working, or I put in the wrong answer. Now, the hope is that you already know what the answer is going to be, and that you already know what the correct answer should be. I could never get by with scalar multiplication because I never really wrapped my head around it when I was in math class. But what I can tell you is that if I did, I would know that the answer is negative 39. And so there is some expectation here that when you're testing, you know what your results are going to be. You know what you should be getting back from that method. You know what data should be coming back to you. And so you can accommodate for that. You can sort of plan and accommodate for that. There are other ways to test as well. This is testing equality of an expected answer versus the result of some mathematical operation or function, or the result of some operation in the system, and making sure that both sides of that are the same. That's what assert equals does. What we're going to do now is take a look at writing some code for test equal, or for the test equal, using assert true and false. So the idea behind assert true and false is for dealing with not numeric values or character values or even string values, but to deal with true and false data. So when we're getting a Boolean value back, we need to decide, when we have a method that returns a Boolean value and we want to check and make sure that it is working appropriately, we can use an assert true, and that's going to assume that the result of whatever operation we put in as an argument is going to come back true. Or we can also use assert false, which means that whatever result of whatever operation we put in as an argument is going to return a false value. So what we're putting in to as an argument is some sort of Boolean statement. Now, that Boolean value could be the result of a method call, as it is in this case. We're calling a method equals, and it's going to return a value, true or false. And if it's true, then if we expect it to be true, then we're going to test it with an assert true. If we expect it to be false, we're going to test it with an assert false. So I'm going to go ahead and put that code in here. I'm going to put that code back. And I'm going to go ahead and start writing my assert true statements and my assert false statements. And then we will take a look at this. So I've gone ahead and entered the code that we have in our handout. And you can see I've changed the system.out.println statement to vectors JUnit 3 test equals. So again, I know that I am testing the test equals method in my, this section is the part that goes with my test equals method in my vectors JUnit 3 test class. Now, what am I asking? Well, first of all, I know that when it comes to vectors, that both arrays have to be identical in order for and equal in order for them to be equal to each other. So an empty array compared to an empty array should be true. So I'm going to use an assert true statement, and I'm going to call the vectors class equal method, and I am going to provide two arrays with no values in them. Same thing should be true, again, an array that contains nothing but 0 and another array or vector that contains nothing but 0 should be the same. They're identical. So again, I'm going to test that with an assert true. A two-member vector compared with a two-member vector, both with the same numbers, again, should be the same. So I'm going to use an assert true. Same thing here with the last two. Since they are identical, and we can even see that they're identical just by looking at them, we are going to test them with assert true. Assert false is what we're going to use when we want to know, here we're testing for length. Are they the same? So I know that a blank array and an array with one item are not the same. So that should return false. So I'm going to use the assert false. Same thing with the rest of these. Down on the bottom here, now I'm starting to look at vectors or arrays of similar size. So this one has 3 items, this one has 3 items. But now I'm going to check to see when their numbers are different, when the values put into the array or the vectors are different. Then what? How do we respond? Well, these two aren't identical. I can see that. They're not the same. This should give me back false. So since I'm expecting false, I'm going to use an assert false. Now, if I'm interested, I can go back to the vectors class, and I can look at the equals method to see what's going on. And basically what we're saying is, if they're both null, then we need to throw an exception because they're null. If the lengths are not the same, then they're not the same. If the lengths are the same, then I'm going to go through and compare each item. And if the first time both items don't match up, I'm returning false. Otherwise, if they pass all of those other tests, then everything is true. So I can just tell by looking at these whether or not they should pass or fail. If it should return true, we would use assert true to see if it is indeed returning correctly. If we expect it to return false, to test against that, we would use the assert false statement. And I'm going to go ahead and run this. Oops. I'm going to go ahead and run it. Just do right-click and run file. And here again, we're running our tests, and it says both tests passed. Test equals and test scalar multiplication. Now, if I just change one of these to assert true, again, I would see an error message, and my test would fail. Let's run this again so we can see what happens when it's wrong. Notice that 50% of my tests pass, 1 test passed, 1 test failed. I have to expand out to find out what test failed. JUnit framework, test equals is my problem. And at line 31, it failed. So that means that I've got an assert true here, but the result was actually false. It doesn't need to tell me because I've only got 2 options. It's either true or false. If I've told it I'm expecting true and it's wrong, then obviously it came back false. So I'm going to change that around so these both pass. And let's just run this test one more time. They're both passed, so everything's good. An exercise